Okay, areas of triangles and quadrilaterals. So area, I mean, you've been talking about area since, I don't know, probably you were in elementary school. And the basic definition of that is area is the number of square units that will completely cover a shape without overlapping. And so one of the earliest area formulas you probably learned was about a rectangle. And we generally teach it as length times width. Although we're going to kind of try to move away from length times width and move to base times height, just because we're going to use base and height on all the other area formulas. So the area formula for a rectangle is the base, basically the length of the base times the height of the rectangle, and that gets us our area. Now, when we get to parallelograms, remember a rectangle is a parallelogram. And so if we kind of go a little bit more general, any parallelogram, if we take it, we can take one of the pointy sides of the parallelogram, and we can slice off that pointy side and basically form one side of a rectangle. And if we take that slice and we move it to the other side of my parallelogram, because I've got two pairs of parallel sides, it will fit and actually form a rectangle. So since we have a rectangle now, we have the formula is the same as was before, the base times the height. So for parallelogram, area formula is base times height. The only kind of kickers here is going to be that on a rectangle it's pretty simple. You took one side times the other side. With the parallelogram we can't do that because while we have the base, which is one of the sides, the other side is not necessarily the height. And so we have to know what the height of the parallelogram is, not just one of the other sides, in order to make this work. Okay. So for example, I've got this parallelogram here, and I know the sides of the parallelogram, but I can use the 18 here to find the area, but I can't use the 10 because the 10 is not the height of the parallelogram. So I'm going to have to do a little bit more work because I know that from here to here is going to be 6, and so I'm going to try to find out what the height of my parallelogram is. Now fortunately this forms a nice little lovely little right triangle, and if we know two sides of a right triangle, to find the missing side we can use Pythagorean theorem. Now I would also hope by now you would recognize, okay, this is a Pythagorean triple because I've got a hypotenuse which is 10, I've got a side which is 6, which means my other side has got to be 8. If you don't recognize this, that's okay. You can still work it out. Same old, the way we've done it before, a squared plus b squared equals c squared. So 6 squared plus h squared equals 10 squared, and subtract it out and all that stuff, and you still get 8. So now that I know my height is 8, now I can find my area. So my area is going to be 18 times 8, which is 144 square units. So, moving to triangles. Now if you take a parallelogram and put a diagonal going down the side, you can cut this thing into two triangles. Well, the area of the parallelogram was the base times the height. So the area of the triangle is going to be half of that, or 1/2 base times height. And you can do this either as 1/2 base times height, you can do this as base times height divided by 2. It doesn't matter to me. I usually, I'll use one or the other depending on circumstances. Whichever you want to do is fine. Okay, a trapezoid. Now trapezoids are a little bit more complicated, but essentially it also still comes out of a parallelogram. If I take a parallelogram and I just put some sort of line going down it, it's going to divide the base into two pieces. And because these my two bases here are the same length, this side of my parallelogram is the same as this side of my parallelogram, that this piece up here, the base 1 on the top is the same as the base 1 on the bottom, on the opposite side on the bottom. The base 2 over here is the same as the base 2 over here. And so the area of this parallelogram becomes the height times base 1 plus base 2. That's the area of it. And so then what happens then is I can split this thing apart into my two trapezoids, which means that the area of one trapezoid is going to be 1/2 of height times base 1 plus base 2. So there gets my formula. So 1/2 of the height times base 1 plus base 2, or height times sum of the bases divided by 2, whichever way you want to do it. Now, the formulas we just used should have been familiar to you from junior high, hopefully. You probably haven't dealt with this next one. So when we deal with a rhombus or a kite, even though they're kind of different shapes, they actually use the same idea to get their area formula. If I take a rhombus or a kite and I split it into two congruent triangles along the diagonal, I end up with these two triangles here, and I want to find the area of one of these triangles. Well, I've got the height of my triangle is 1/2 of one diagonal. The base of my triangle is the other diagonal. Whether I'm talking about the rhombus or the kite, it works the same way. So one of these triangles is going to be 1/2 of, because remember my area formula for triangle is 1/2 base times height. So 1/2 of my base, which is diagonal 1, times the height, which is 1/2 of the diagonal 2. Multiply all that together, and you get 1/4 of, or 1/4 diagonal 1, diagonal 2. Well, again, the rhombus or the kite, we've made it into two triangles, so if I double that, I get 1/2 diagonal 1 times diagonal 2. And that is my formula for a rhombus or a kite. Now, since a square is also a rhombus, see, a square we generally use the rectangle formula with a square, base times height, which is the same, so we end up with side squared. But a square, since a square is also a rhombus, it can also use the rhombus formula. So the area of a square can also be 1/2 diagonal 1 times diagonal 2. Just depends on the information you're given, which formula you want to use. So for example, let's say I've got a kite, and I know that one diagonal is 12 inches, and I know the area is 96 square inches, and I want to find the other diagonal. Well, here's my formula, diagonal 1, diagonal 2 divided by 2. Plug in what I know and solve for what I don't know. So that means that 96 is equal to 12 times diagonal 2 divided by 2. If I've got an odd diagonal here, I would multiply both sides by 2. Since I've got an even number here, I'm just going to reduce this fraction, so 12 divided by 2 would be 6. So then I just divide both sides by 6, and I get diagonal 2 is going to be 16 inches. Okay, so we're going to do quite a bit of practice on this, so hopefully you'll become more comfortable working with these different formulas. But you need to be able to recognize which formulas go with which shapes, and be comfortable working both when you're given the information and find the area, or if you're given a piece of information and the area and have to find another piece. So that's kind of the process we're going to be working through with this.